Hi, grade 8 students. Today is day 15. You have two locations where you need to be looking for your assignment today. One of them is page 505. You'll be doing problems 1 to 6. And one location is 510, numbers 7 through 23, the odds. In that first section, you'll be talking about symmetry, whether it's line symmetry or rotational symmetry. And in that second section, you're going to be talking about different types of transformations, whether they be or transformations, whether they be translations, which are slides, reflections, which are flips, and rotations, which are turns. Do you remember these formulas we had last time for rotations? You might want to write these down. They may help you in solving any rotation problem that you're facing when you get into this. I'm going to ask you to pause this video for a few minutes, look at those pages, look at the example problems, and then come back and we'll discuss some examples. Okay, thank you for taking your time to look at that. Let's talk first about the concept of line symmetry. If I were to draw a heart, please do not grade my artistic ability in drawing hearts. And if I were to say to you, does that figure have line symmetry? Hopefully, you've had line symmetry and rotational symmetry at least the last 2 years in 7th and 6th grade. You would recognize that there is line symmetry right down the middle, that if you fold this one on top of the other, they would be identical but in reverse of each other. So the left half of the heart and the right half of the heart would match if I could draw this perfectly. If we talk about a shape like, let's say, for example, the symbol of the Red Cross here in the United States, does that have line symmetry? Again, if I drew this perfectly, it would have line symmetry right here. It would also have line symmetry here, but it would also have line symmetry here and here as well. So the Red Cross symbol has 4 lines of symmetry. Now, what about that concept of rotational symmetry? Let's imagine that we took a look at the letter N, the capital letter N. If I were to take that capital letter N and churn it 180 degrees so that this point ends up down here, it would look identical. We're pivoting it on a point that's in the middle of the letter. And in that case, the letter N does have rotational symmetry. So one would say, yes, it has rotational symmetry, and it has rotational symmetry of 180 degrees because you have to turn it 180 degrees to get it to look the same as it did originally. Let's try it with a different figure. Now remember, imagine I drew this perfectly. Imagine we have a perfect 5-pointed star. Does that have rotational symmetry? Yeah, it does. Remember, we're talking about a perfect star. This is not a perfect star. All I would have to do is rotate this point so that it's right here, and then this point would end up here, and it would look identical. How far did I rotate it? Well, we know that a full circle is 360 degrees. We know that this has 5 points. If I divide 5 into 360, I'd have to rotate that circle, or that star rather, 72 degrees to get it to look the same. So yes, it has rotational symmetry of 72 degrees, but guess what? It's got some other degree measurements. We could rotate it 144 degrees. In other words, if I take it from here down to here, we could rotate it, let's see, 216 degrees if I rotate it from here all the way around to here. Or we could rotate it 288 degrees. If I rotated it from here all the way around to this spot, it would still look identical. So that star does have rotational symmetry. What if I drew a letter like, say, for example, the letter L? Does that have rotational symmetry? No, it doesn't. The only way you could get it to look the same by rotating it is if you rotated it an entire circle of 360 degrees, and that's not what we're talking about in regards to rotational symmetry. Okay, so that's some help, hopefully, for page 505. I'm going to give you some hints on 505 on problems 1, 2, and 3. 2 of them have line symmetry, 1 of them does not. So the one that does not have line symmetry, just write none. At the bottom of the page, 4, 5, and 6, 2 of them you're going to write yes because they have rotational symmetry. 1 of them does not have rotational symmetry. Now let's spend a little time talking about translations, reflections, and rotations, just to make sure that you remember how to do them. And we're going to take this with us, and we're going to move it over here and take a look at this board and hope that the overhead screen doesn't churn off during the middle of our video. Let's start first with translations. Translations are sometimes, ooh, I get a grid on my face, wow. Translations are sometimes also called slides. Let's imagine that I had a figure that was right here, basically a triangle, and somebody said to me, translate this, or in other words, slide it 3 to the left and 5 down. 3 to the left and 5 down. What would you do? You take each dot individually and go 3 to the left and 5 down. So that would be 1, 2, 3, 1, 2, 3, 4, 5. That would be our first dot. 1, 2, 3, 1, 2, 3, 4, 5. Second dot. 1, 2, 3, 1, 2, 3, 4, 5. That would be our third dot. So this is an example of a slide. Remember, oh, there goes the board. If we call it ABC for the original figure, the new figure we would tend to call A prime, B prime, and C prime. Let me get that screen back. Okay, hopefully that'll last for the remainder of the video. So this is an example of a slide. We just simply take the figure, move it 3 places to the left, 5 places down, whambity-bambity. Next one we're going to talk about is, what in the world's a reflection? Well, imagine we draw a shape that looks like this, the letter L. And imagine somebody says to me, reflect this over the y-axis. And it's important we know, am I reflecting it over the y-axis or the x-axis, because that determines where the shape's going to end up. In this case, we're going to do it over the y-axis. And we're going to identify some points as A, B, C, D, E, and F. So we've got, what is that, 2, 4, 6 different points. Here's our y-axis. A is 2 units away, so we're going to go 2 units away on the other side of y, and there's our A prime. B is 4 units away, so we're going to go 4 units away, and there's our B prime. D is 3 units away, so we go 3 units away. There's our D prime. C is 4 units away, so there's our C prime. E is, let's see, 1, 2, 3 units away. So we're going to go 3 units away for E prime. And F is 2 units away. So we're going to go 2 units away for F. 1, 2. So there's our F prime. And our new shape looks like this. Notice how it's been flipped to the other side of the y-axis. Okay, what if somebody says to us, no, don't flip it over the y-axis, flip it over the x-axis instead, this axis? Well, it's the same idea. This would be our A prime here, our B prime, our C prime, our D prime, our E prime, and our F prime. Because A is 1 away from the x-axis, so we go 1 away on the other side of the x-axis to find A prime, and likewise for all the other dots. That's how we do reflections. But What if somebody gets tricky and puts a dot here, and say a dot here, forms a triangle, and says flip this over the x-axis? How do you do it when you've got dots on either side of the x-axis and they want you to flip it over the x-axis? No panic. If this is our A, our B, and our C, we usually do it the same way as we've talked about before. There you go. A prime is 1 away, just like A is 1 away. B prime is 1 away, just like B prime is 1 away, and so on through the pattern. That's a reflection. Finally, the last transformation is called a rotation. We're going to start by drawing a triangle. And we're going to identify the locations of these dots. That's 1, 1. This is 4, 1. And this right here is 3, 3. And let's say somebody says to you, rotate this or turn this 90 degrees counterclockwise. Counterclockwise. In other words, this direction. Well, I'm going to use the middle rule. Write the ordered pair, flip the ordered pair, and make the y value its opposite. So write the ordered pair, flip the ordered pair, and make the y value its opposite. So this dot of our triangle is going to end up at -1, 1, which is right here. We'll do it for all the other dots. This would become, what, 1, 4, but we make the y its opposite. -1, 4 would be, let's see, right here. And this dot would become 3, 3, but we make the y its opposite. So we get -3, 3, which would be right here. So here are our new dots. And this is the rotation, 90 degrees counterclockwise. If I called this A, and this B, and this C, now this would be our A prime. Our B prime would be here, and our C prime would be up there, because we rotated it counterclockwise. Okay, let's try it with the same starting coordinates, but this time let's rotate it clockwise 90 degrees. In other words, I want the figure to end up down here in quadrant number 4. The pattern is flip the coordinates and make the x value its opposite. Flip the coordinates and make the x value its opposite. So this one would become 1, -1. We flip the coordinates and make the old x value its opposite, and that would be right here. If I flip these coordinates and make the x value its opposite, that's 1, -4. That's right here. And this would become 3, -3, which would be right here. And our locations would be A prime, B prime, and C prime for this particular circumstance. Finally, how do you handle a 180 degree rotation? Well, the pattern says change x, y into -x, -y. You don't flip them, you just make them their opposites. So that means A would end up here, C would end up here, and B would end up here. Because all I did is make them their opposites. And there we have the rotations. If you have any questions, feel free to give me a call. My number is 517-242-3138. Thank you and have a good day.